Welcome to part 1 of the PKU Designer Utility tutorial. Here we've got a GUI showing controls for PKU 2200, the designer window where we can define our CAN message that's transmitted and received by the module, the actual CAN messages that are being transmitted from the computer to the module, which has a video screen capturing the current state of it. So right now we have a message that's being transmitted and received by the module, and we can control it from the screen here. You can see the data changes down in the message transmitted to turn these LEDs red on the actual module. When the button on the module is pressed, you can even see the data change on the screen visually and also in the message. So what we're going to do is show off some of the features that are capable with the new designer utility. So we've already got our messages defined, but we want to go in and make sure that the switch states are also defined. So for switch 1, we have the bit position for that switch in the message index defined, and we have it listed as a momentary switch. So if I press switch 1, I can see bit 1 changing, and it remains held or pressed as long as I'm holding it down. For switch 2, we've defined it as a toggle. So if I press switch 2 and release, the data is still latched, and you can see visually that it's still there. Now the interesting thing with the toggles is that we can actually force other switch states to be cleared when that toggle is pressed. So we've also defined switch 4 as a toggle in bit position 6. So if I press switch 4, this radio control mask here basically tells it to clear all of the other switch states except for switch 4. Same thing with switch 2. It'll clear all the other switch states except for switch 2. So if we press switch 2 and then press switch 4, it's going to clear both of those. Now once it's latched, you can press any of the other two switches. You can see the data change, and it remains latched throughout. So along with the toggle 2, there's also a toggle 3 or toggle 4 that would allow you to step through various settings or power levels. Along with the transmitted portion of the switches, we can also define what controls the LED associated with that switch. So for all of our switches, we're reserving 16 states, and you can see the active states listed in the side of the window here. So for each received switch, we're going to start at the very first bit position and then reserve 4 bits to decode into those 16 states. Switch number 2 will start at the 4th bit position and also have those same 16 states. We can go into our state editor and determine what each of the states will actually represent on the keypad. So right now we've defined state 1 as being off, and we've got state 2, which is actually when you transmit a value of 1, which is what's currently on the keypad, defined as red. So by pressing on our GUI, we can go through and cycle through all the possible states. So we've just changed the first switch to green. It should be a solid green. If I go back to the active state here, you can just follow through the list as we go down. So we have green, yellow, blue, magenta, cyan, and white. Now that covers all of the solid defined colors. Next up, we're going to be doing some of the visual effects that you can apply. So you can have a spinning effect. In this case, we're doing a counterclockwise green spin, which you can see in the state editor from state number 9. Now within the state editor, we can change the color, we can change the visual effect, we can change the speed, and for the spin we can even reverse polarity. So you'll see the speed is defined as 10, where the larger numbers would be a faster speed, slower numbers would be a slower, or lower numbers would be a slower speed. For the next state, we've defined state number 10 as a red, but we reversed the polarity. So now you can see that it's going in the clockwise direction. If we put two of them together, you'll see they're counter-rotating, and if they're the same, they actually sync up, so you can have two devices that would match the spin cycle and rate here. We also have some additional effects. So beyond the spins, we have a pulsing effect. So if we move to a pulsing effect, this is a slow pulsing green effect. You'll see the speed is defined as 1, so it's a very, very, very slow ramp speed. And if we switch to our faster pulsing effect, you can see the blue color in the second position here is ramping at a much faster rate. And in the designer window, the speed is set to 8. We also have some additional visual effects. We have a blink, so very slow blink for the third switch here, which is using a speed of 2. And for the fourth switch, we have a faster blink with a yellow indicator. And in the state editor, the yellow is blinking at a speed of 12. The last two, I don't know if they're going to show up in the video, is a ripple effect. And the ripple effect basically has, it's a combination of the pulsing and the spinning. So each of the 3 LEDs underneath the indicator will rotate and alternate which LED is active, but it'll also ramp up that LED to create kind of a rippling effect in it. I'm not sure if you can tell the magenta and cyan effects here. I think that covers all of the state effects for each of the individual switches. If I go ahead and reset it and put all of them back to a solid color, we also have a brightness tab in the designer window where we can define what bit index our backlight and primary brightness are associated at. So I have a brightness that I can control here. You can see the 2 bytes in the message corresponding to this percentage level here, which is full scale is 255. And then if I went all the way down, you pretty much can tell that it's barely on right now. So we can control our brightness, we can control what our switch effect is, and we can also control what the switch is sending out to the rest of the system. That'll conclude part 1.